Okay, so let's start. Let's pick up from where we left off. So in the last class, we still hadn't done anything new except for the theoretical part. Today, hopefully, we will reach a point where we will cover something new, and that's going to be variance and standard deviation. Okay. All right. So let's start. In the last class, we learned how to calculate mean, median, and mode, but the kind of data that we were dealing with was discrete data. Okay. Today, inshallah, we're going to learn how to calculate again the mean, median, mode, but this time we're going to be dealing with group data, and we are going to be dealing with grouped and continuous and also grouped and not continuous data. Okay, so plenty of concepts to cover today, inshallah. So median is resistant to extreme values. Okay, so if you add extreme values, doesn't matter if you add an extremely large value or if you add an extremely small value. So when you add an extremely large value and if the data is arranged in an ascending order, that value will be towards the very end. And just like that, if you add an extremely small value, and again the data is arranged in ascending order, which it will be if you're calculating the median, then that's going to be at the very beginning and it won't impact your median. Okay, so that's why for whenever you have like a lot of difference in when you don't have a lot of consistency in data, that's when we prefer median over mean. Okay, so I hope that answers your question. Okay, great. Acha, so since the concepts that we're gonna do today will mostly be revision for you guys in the sense that we've already dealt with them when we were doing O levels, so that's why we're not gonna go in a lot of theory. Okay, we're just gonna straight away start with an example question. So here you can see that again we are doing mean, median, and mode. But what's the difference? How is this question different from the questions that we did in the last class? We have data, we have to find mean, median, mode, but what's the difference compared to the question that we did in the last class? Like take this question, for example. It's very clear. Yes, frequency. Okay. What we have here is group data. Okay, now we call this group data, but this is basically grouped and discrete in the sense that the groups are basically of discrete values. So yes, it's group data, but the values are discrete in the sense that this one itself is a group. Okay, this 2 itself is a group. So it's not like here the frequency 15 is representing the frequency of something other than 1. It's just the frequency of 1. Okay, so that's why we call this group data, but we further categorize it and say that it's grouped and discrete. If you remember, that's what we did in the last class as well. We saw that there are plenty of ways to group data. You can do them through discrete values, class intervals with continuous range, and class intervals with not continuous range. Okay, so let's calculate the mode. The mode is a no-brainer in this case. You can just eyeball it and tell me what the answer is going to be. Is it going to be 25? Let's see if you guys fall for the trap. Is 25 going to be the mode? Somebody's mic is open. Would appreciate if you put yourself on mute. Yeah, the answer is going to be 2. Okay, remember 25. It's with the help of 25 that we find out the mode, because 25 is the highest frequency. And what is 25? The frequency of 25 is the frequency of 2. So that's why 2 is our mode. Okay, now what do we do for median? What are we going to do for median over here? Again, something that you guys must have done in O levels 16. Oh, sorry, 3. Okay, Abdul Nafe, did you do some calculations, or is that an estimate?
So I basically added the frequencies and then I divided the frequencies by 2. Like it was 100 plus 1 divided by 2, and the
ठीक है.
50.5th value was the median.
ठीक है, sure, that's correct. So basically, if you add all the frequencies, although sometimes you don't have to, it's given in the question. Like for example, here it says 100 times. So we don't really have to add all the values. All you got to do is 100 plus 1 upon 2. Okay, and we're looking for 100 plus 1 upon the 2th term. Okay, which kind of becomes, this 0.5 kind of becomes irrelevant because 100 plus 1 is 101 divided by 2 is 50.5. So we're looking for the 50th term and the 51st term. And if they're both the same, that means that term is going to be our median. So let's see. 15 plus 25 is what? Is 40. 40 plus 16 is what? 40 plus 16 is 56. So that means we have our 50th and the 51st term. Since they're both 3, That means the median is also going to be 3. Okay, good job. Now, what about the mean? What do we do if we're finding out? Yeah, yeah.
So we wanted 50.5 term. So we have 40 and we have 56. So which term will you take exact?
No, no, I'm not taking 40 or 56. This 40 means that the 40th terms are till 2. Okay, then this 56 means that after the 40th term, the 41st term, up until the 56th term, they're all 3. So that means the 50th term as well as the 51st term, they're all 3. That means the median is 3. Okay, remember this data that we have in group form, this is not how it must have been. Okay, in fact, this is not how it was before it before we formed a frequency table. It must have been in discrete form. Okay, like for example, the frequency of 1 is 15. What does that mean? That means 1 must have been occurred how many times? 15 times. Okay, the frequency of 2 is 25. That means 2 must have occurred how many times? A total of 25 times. The frequency of 3 is 16. That means 3 must have occurred a total of how many times? 16 times. Okay, what are we looking for? We're looking for the 50th and the 51st term. We're looking for the 50th and the 51st term so that we can take out their average. So if 1 occurs a total of 15 times, that means 1 starts from the first term and we have 1 till the 15th term, correct? And if 2 occurs 25 times, that means from the 16th term all the way to the 40th term, what do we have? We have 2, 2, 2, 2, 2. Okay. Then what comes after the 40th term? The 41st term, which is going to be 3, and we will continue to have 3 till we get to the 56th term. Now, can you tell me what the 50th and the 51st term is going to be?
So what did you ask?
My question is, can you tell me now what the 50th and the 51st term is going to be?
3.
3. Okay, and if you take the average of 3 and 3, what do you get? You get 3. Okay, if you take the average of 3 and 3, that means 3 plus 3 upon 2. You must have done this in O levels, Fatma. You just need to revise it a little. If you take the average of 3 and 3, the answer is going to be 3 as well. Okay. All right. Now, what about the mean? How do we find out the mean? What do we do over here? What's the formula?
We multiply frequencies with the number and
That
divide by 100.
That is correct. So sigma fx or summation fx divide by summation f. All right, somebody's given me the answer already. That's brilliant. But let's just write it down. So frequency multiplied by 1 plus 25 multiplied by 2 plus 16 multiplied by 3 plus 20 multiplied by 4 plus 13 multiplied by 5 plus 11 multiplied by 6 divided by the total frequency, again, which you will find if you just read the question. And let me see if 3.24 is the correct answer. Just a minute, hang on. By the way, there are ways actually that you can do this in your calculator. I think I'll make a video on it. You can find mean in your calculator. You can enter all the table values. Yeah, so 3.24 is the correct answer. Yes, the formulas will be given, okay, but this is not exactly a new formula, okay? This is a formula that we had in O levels as well. So, nothing new so far, and this is how you calculate mean, median, and mode of group data such that it's in discrete form. Let's write down today's date. It's the 4th of Feb 2024. Okay, now let's look at how to calculate the mean, median, and mode when you have group data but in continuous form. Okay, so again, for this also we'll do an example. We're not going to waste our time first learning the concept and then doing an example.
Sir, these are past papers.
No, these are not past paper questions, okay? All right, now, this is, again, we're just going to go over the mean. We're not going to go over the median and mode. Okay, we'll do that later. So here, we're supposed to calculate the mean, but what kind of data are we dealing with? We're dealing with group data. But what kind of group data? We're dealing with group data that is in continuous form. So yeah, let's hope so. Let's hope that we have enough time that we can do past paper questions today. Okay, I think we will. Yeah, we will. When we're doing variance, we'll do some example questions through past papers. Okay. All right, so why am I calling this data continuous? Grouped, I know everyone can agree that this is group data, but why am I calling it continuous? Yes, it is in interval form, but why am I calling it continuous? It's group data in interval form, but it's continuous. And the reason why it's continuous is because you can see that it ends at 32.5 and the next interval or the next class starts at 32.5. Here, this class ends at 38.5 and the next class starts at 38.5. Yeah, exactly. There are no gaps, no jumps. Okay. So if I want to calculate the mean over here, since that's what we're supposed to, how do I do that? What do I multiply the frequency with?
The midpoint.
The midpoint. Okay, so here what I'll do is, yes, here I will calculate the midpoint. Okay, so how do we calculate the midpoint?
You add them and divide by 2.
That is correct. You add them and divide by 2. So here you get 26.5, 32.5. Yeah, exactly. This is all same as O level. Okay, nothing new. This is just a refresher. Divide by 2, which is 35.5. And then 38.5 plus 44.5 divided by 2, which is 41.5. And then 44.5 plus 50.5 divided by 2, which is 47.5. And then 50.5 plus 68.5 divided by 2, which is 59.5. Okay, and what's the formula? The formula is exactly the same. Mean is summation fx over summation f. The only difference is that x here is the midpoint. Okay. So 30 into 26.5 plus 80 into 35.5. Achha, I'm not going to write the entire thing. I'll just skip a few values and then write down the value that we have at the very end. 60 into 59.5. Okay, and then this is divided by the total frequency, for which you can just read the question. It says 320. So there you go. That's your answer. The reason why we do this is because all the values in between 20.5 and 32.5 end up in this group. Okay, so we don't know how many values we have which are 20.5, 20.6. I mean, you can have so many values and all of them could be different. Like, it's possible that all these 30 values are different. So that's why what we do is we decide an interval and then we take its midpoint. Okay, that gives us an estimate. It does not give us the actual mean. It always gives us an estimate, which is why whenever you have group data such that it's in continuous form or interval form, the question will always ask you for the mean, estimate of the mean. It will never ask you to calculate the exact mean because it's just not possible. Okay, so we do this so that we can estimate what the mean is. Okay, now we have another question. The answer will be, okay, I haven't really worked out the answer, but here I'll just I'll just copy the answer from the book and then you guys can cross check. Just a minute. 43.1. Yeah, 43.07, which is going to be 43.1. Remember, 3 significant figures. Final answer are always supposed to be correct to 3 significant figures. Okay? Now, tell me, what is the difference between this question and this question? You're welcome. This is measures of central tendency. It's written right here. Okay. Yes, there are gaps in it. Okay. Here we have gaps. So this also is group data. Okay, it's group data which is in class interval form, but the problem is that the class intervals are not continuous. Okay, so first of all, if I want to convert this data into continuous form, what do I have to do? If I want to convert this data into continuous, this is something that is perhaps new for you guys. Okay, we do have this. We do have this in O levels, by the way, but we barely get questions on this. You guys remember upper class boundary, lower class boundary? Okay, just a minute. So here, what we're going to do is we're going to convert this data into continuous form. Okay. Now first pay attention to how that is done. Okay, and then I've left one column so that we can calculate the midpoint. Okay, Fatma, please pay attention. Hold on. Have some patience. You'll find the answer to your question. Okay, and that goes for everyone else as well. Now, here we have the height. Okay, and what we have to do is we have to convert this data from the way it is into continuous form. Okay, how do we do that? So this is the method of converting data from converting data with gaps in it to continuous form. First of all, what is the difference between where the first class ends and the second class starts? What's the difference between 119 and 120? What is the difference? 1. Okay. Now divide 1 by 2. 120 minus 119, that's 1. What's 1 divided by 2? 0.5. Okay, now pay close attention. Here's what we do. We add 0.5 to 119. Okay, so we add 119 to the upper class boundary. This is called upper class boundary. And we subtract 0.5 from 120. Okay, so once again, pay close attention. What's the difference between 119 and 120? 1. What do we do with that 1? We divide that by 2. What do we get? We get 0.5. We add 0.5 to 119. We subtract 0.5 from 120. So what happens as a result? This becomes 119.5 and this becomes 119.5 as well. Now what's happened all of a sudden? This from gaps in them has become continuous. Okay, and then again, what's the difference between 129 and 130? Again 1. What do? We divide that by 2. We get 0.5. We add 0.5 to 129, so it becomes 129.5. We subtract 0.5 from 130, so it becomes 129.5 as well. And here, the data is such that the gaps are consistent in the sense that the gap is always off 1. So that means 139 will now become 139.5. 140 will also become 139.5. 149 will become 149.5. And this will also become 149.5. 159 will become 159.5. This will also be 159.5. And then 169.5, 169.5 to 179.5. And then 179.5. Okay, now notice something. I left this value, the first value, and the last value. Now, how do we figure that out? So for that, we see what we have done throughout. What have we done throughout? We have added 0.5 to the upper class boundary and subtracted 0.5 from the lower class boundary. So that's what we're going to do. That means we're going to subtract 0.5 from 110. So that becomes 109.5. And we're going to add 0.5 to 189. So that becomes 189.5. Okay, so this is how you convert data from non-continuous form to continuous form. Okay, now before we go ahead and find out the mean, let me know if you have any questions regarding this concept. And did you guys do this in O-level? No? Acha, why this helps? Okay, that's a good question. This is basically necessary because if you have to make a histogram, okay, or if you have to make cumulative frequency. Now, what's a histogram like? Do you guys recall a histogram? Are all the bars connected, or do all the bars have spaces in between them? They're connected, okay? So because they're connected, that means the ranges must also be in continuous form, okay? Now, let me tell you something. In fact, I want you guys to figure it out. Do you think adding 0.5 and subtracting 0.5 and without doing that, will it have an impact on the midpoint? Think about it. Find out the midpoint of this range and find out the midpoint of this range. You think there will be an impact? There won't be any impact. Why? Find out the midpoint of 110 and 119. Okay, let's do that. So let's do that as we speak. 110 plus 119 divided by 2. So we get 114.5. Okay, so here I'm writing down the midpoints. Okay, and if I calculate the midpoint using these two values, where I've added 0.5 to the upper class boundary and subtracted 0.5 from the lower class boundary, let's see what happens. 109.5 plus 119.5 divided by 2, we get the same answer, 114.5. Okay, now chances are that if you're supposed to calculate the mean, this will not be necessary. Okay, chances are that if you want to calculate the mean, this will not be necessary. But this will make a difference. Adding 0.5 and not adding 0.5 will make a difference if the data is starting from 0. If let's say there was 0 over here, okay, in that case, we don't subtract from 0. Why? What happens if I subtract from 0? Subtracting from 0 means it's going to become negative. And what are we dealing with over here? We're dealing with height, and usually we're dealing with scalar values such that they can't be negative. So I'll make you guys write down a note which will answer your question as to why do we do this and when do we don't do this. But this is how you convert data which is not in continuous form into continuous form. Okay, so this is an important note. In order to calculate mean, it is not necessary. Now, we don't always add 0.5. Remember, I said we first look at the difference between where the upper class boundary, where one class ends and the other starts. We take that difference, we divide by 2, and then we add and subtract that. Okay. In order to calculate mean, it is not necessary to turn the data into continuous form as midpoint remains the same, except, okay, except if the range is starting from 0. Okay, now I'll put a star over here because in this question, we don't have the range starting from 0. We'll do a question where the range is starting from 0, and then we'll see how we treat that data. Okay, so in this case, because the range is not starting from 0, it doesn't matter whether I convert it into continuous form or whether I don't convert it into continuous form. The midpoint remains the same. But if you have a data where it's starting from 0, in that case, if you don't convert it into continuous form, then your answer can be different. Okay, in that case, you have to convert it into continuous form. Okay, now the gaps will not always be 1. Like, for example, you can have something like this. Let's say you have 2 to 5, and then you can have 7 to 10, and then you can have 12 to 15. Okay, let's say this is the case. So what are you going to do now? Here, you will look at the difference. Also difference between 5 and 7, 2. So you divide that by 2, what do you get? You get 1. So you add 1 to 5, it becomes 6. You subtract 1 from 7, that becomes 6. Okay, so it depends on the question. You look at the difference, you divide that by 2, you add that value to the upper class boundary and subtract to get the lower class boundary. Okay, that's how this works. All right, now finding out the mean in this case is pretty much the same as the previous question. Okay, you will find out all the midpoints. Okay, and then you will take the midpoint, multiply it by the frequency. What if the gaps are not? That's fine. Even if the gaps are not constant, you look at, understand the method. Then no matter what the gap is, you can find out, you can convert the data without any help. So here, like for example, let's say you're dealing with something like this: 2 to 5, 7 to 10, 11 to 15, 17 to 20. Okay? Now, are the gaps continuous? Are the gaps consistent? No, they're not. Here there's a gap of 2, here there's a gap of 1, here there's a gap of 2. So understand the method, okay? Don't make separate rules for separate methods. Understand the method. What's the difference between 5 and 7? 2. Okay, you divide that by 2, what do you get? You get 1. So you add 1 to 5, you get 6. You subtract 1 from 7, you get 6. Okay? Then you look at 10 and 11. What's the difference? The difference is 1. Divide that by 2. What do you get? You get 0.5. So you add 0.5 to 10, so that it becomes 10.5. You subtract 0.5 from 11, so that becomes 10.5 as well. Okay? Then what's the difference between 15 and 17? The difference between 15 and 17 is 2. You divide 2 by 2. What do you get? You get 1. You add 1 to 15. It becomes 16. You subtract 1 from 17. That becomes 16 as well. Okay. Now, the question is, what do we do for the first one? And what do we do for the last one? Okay. Now, for that, pay close attention. For the first one, we do exactly as we did with 6. Okay, how did we get this 6 over here? We subtracted. Okay, so in this case also, we will subtract 1 from 2. And here for the last one, what are we going to do? What was the difference between the second last and the last one? The difference was of 2, so that's why we subtracted and we added 1. So here also, we're going to add 1 to 20. Okay, that's how this works. So again, look at the difference, divide that by 2, add to get the upper class boundary, subtract to get the lower class boundary. Okay, yes. So in summary, if non-continuous starts from 0, then this is compulsory. Otherwise, it's not. Okay? Yeah, that's a nice way to sum it up. All right. Now, when we get to some questions, you will have an understanding as to when this is absolutely necessary and when this is not. Yeah.
So then why did you convert that table in the previous question into continuous?
Okay, the reason why I did that so that we can learn how to do it. Because at some point we will have to, right? So the reason why I did that is so that we can learn how it's done and then decide whether it's necessary or not. Here, you're right. If I didn't convert it, we would have gotten away with it. But we still have to learn. And when is it absolutely necessary to convert the data into continuous form? When we have to make a histogram or a cumulative frequency curve. Let's write that down also. Another important note. To make a histogram or a cumulative frequency curve, we must convert the data into continuous form. Okay, and how do we convert it into continuous form? Now you guys know. Okay. All right. If the note that you have written above is for non-continuous. Yes. The note that I've written over here is for non-continuous. Okay. So if you have, again, long story short, if you have non-continuous data, then what do? We see if it's starting from 0. If yes, then we convert it into continuous form. Okay. If it is not starting from 0, we don't convert it into continuous form. If and only if we have to find the mean. Okay. Secondly, if you have to make a cumulative frequency curve or if you have to make a histogram, then you must convert it into continuous form. Okay. If you also want, okay, now hold on to that. The reason why I didn't do median for questions like these is because normally in questions like these, the question will ask you to find the median through a cumulative frequency. Okay, so when we get to cumulative frequency curve, you'll find the answer to that. Okay, the thing about stats and M1 is that everything is interconnected. So when we pick a concept, we have to do part of a concept in one chapter and the remaining part in the other chapter. Okay, so this is something that you guys will have to put up with. But once we're through with the first 2 chapters, you will have an understanding as to when we have to convert and when we don't have to convert in everything. Okay. All right. Now, what we're about to start now is something that is absolutely new for you guys. Okay, in the sense that we don't do this in O levels or ad maths. We don't do this anywhere. Okay, and this is called variance. Okay. Now, there are some very lengthy formulas that we're going to be dealing with, so please have some patience. Don't immediately give up and don't immediately start asking questions. You guys are very welcome to ask, but first, please let me finish and let me do a couple of example questions, okay? So, variance. Anyone has any idea what variance is by definition? What do you think the word variance means? Difference, okay. Options in, okay, that's variance. Options in certain thing, that's variance. That's not variance. So variance is basically, it is standard deviation. Okay, yeah, that's true, but that's still not how you define it. Change, okay, yeah. So a better definition would be that it is a measurement of the spread between the numbers in a data set. Okay, or in other words, it helps us find out how consistent the data is. Okay, it helps finding out how consistent the values are. Now, what does that mean? So let me give you an example. You guys all watch cricket? Pretty sure you do. Yes or no? No? Okay. All right. Those of you who don't watch cricket, you are aware of what it is, right? You're aware of how it works. Okay. So what does a batsman do? Yeah, hits the ball. Yeah, is it like baseball? Lamar, where are you from? It's not like baseball, but kind of like that, except that the scoring and all of that is different. Okay. Better version. Okay. Well, I haven't seen baseball. Like, I've never seen a baseball game, so I really can't say. But yeah, it's kind of like baseball. Okay. So let's say you have two batsmen. Okay, A and B. Okay, and you want to pick one for an upcoming tournament. Okay. Now, if you look at the scores of A, we see 50, 40, 30, 10, and 70. Okay. If you look at the scores of 40, 45, of batsman B, you have 40, 45, 37, 42, and 36. Okay. Now, surprisingly, if I take the mean of both the batsmen, if I take the average score of both the batsmen, you will notice that 50 plus 40, 90, 90 plus 30, 120, 120 plus 80, that's 200. 200 divided by 5, that's 40. Okay, and then if I take the mean of B, the sum here also is 200. 200 divided by 5 is equal to 40. Okay, now both these batsmen have the same average. Okay, but if you had to pick one, which one will you pick? And I want to know why. Okay, B. Yes, we will pick B over A. Why is that? Why is that? Because B is relatively more consistent. Yes, strike rate and all of that, I agree, that matters, okay? But B is relatively more consistent. Yes, he doesn't have a high score of 70, but if you look at his scores, their scores are high, okay? And they're also consistent. Here you have a 10 and a 30, and then all of a sudden you have a 70. So these are not, I mean, these are good scores, but not all of them are good. So which batsman is more reliable? Even though they both have the same average, but which batsman is more reliable? Batsman B is far more reliable, okay? Now imagine that you have 100 values. Now here it's easy for us to eyeball who's more reliable, right? Because we don't have a lot of data, we don't have a lot of values. But if you have a lot of values, then that means you want something other than just the average, which will help you make this decision. Now remember what I said at the very beginning, that the whole idea of studying statistics is so that we can make informed decisions. Okay, and for informed decisions, we need data so that we can use that data, run some do some calculations, and then make that decision. So that is where we use variance. Okay, variance tells us how consistent your data is. Okay, so remember the symbol of variance. The symbol of variance is basically sigma squared. Okay, this is what the symbol of variance is. It's sigma squared. I'm just writing this down in words. You don't have to write this. Sigma is basically this symbol, okay, and there's a square on it. And why is that? Because we have something also similar to variance, which is called standard deviation. More about this later. First, we're going to focus on variance. Standard deviation is basically the square root of variance. Okay, and the symbol for standard deviation is just sigma. Okay, more about standard deviation later. Right now, remember, variance is what? In theory, it helps us finding out how consistent the values are. The symbol for variance is sigma squared. Okay, now, what is the formula to calculate variance? Okay, let's talk about that. What is the formula to calculate variance? Now you can see here that I've made two arrows. Now, why do you think I've made two arrows? The reason why I made two arrows is because we have a different formula for group data and we have a different formula for ungrouped data. Okay, variance. All right. And within ungrouped data, there are two formulas. So a lot of formulas coming your way. Ungrouped data. We'll discuss it in detail later. Okay, that's what I said. Please pay attention. We'll discuss standard deviation in detail later on. So sigma squared is equal to summation x squared upon n minus summation x over n, the whole thing squared. Okay, and what is summation x over n? It's basically mean. So here's what I'm going to write this as. Instead, it's going to be minus mean squared. Okay, so I'll write this down over here, that mean is now what we write as x bar, and that is sigma x over n. Now this is one formula, or there is another formula which is sigma squared is equals to summation x minus x bar, the whole thing squared over n. Now I know at this point those of you who are doing it for the first time are probably freaking out what these values, what these symbols are. Don't worry about it. You will find, you'll get comfortable with these. But at the moment, let's just write it down and then we'll see what's what. Okay. Now what do we do when we have group data? Let's see. So here's what the formula for variance is for group data. Okay. It's sigma squared equals to summation fx square over summation f minus the square of mean, or there's another formula which is sigma squared equals to summation f x minus x bar, the whole thing square over summation f. Now again, like I said, those of you who are looking at it for the first time will probably freak out. Nothing to worry about. So this is the formula. I would suggest you guys write it down. Okay, although we will be writing it again and again, and yes, you will have this formula given to you. But again, if you're one of those who has to do a lot of back and forth, look at the formula again and again, that means you don't have an understanding of the concept. That means you haven't practiced well enough. The reason why you guys know the quadratic formula at this point is because you've practiced it well enough. So just like that, not immediately, but after a certain point, you will be in a state where you won't have to see what the formula is. You will have it memorized. But if you don't have it memorized, that means you haven't practiced it enough. Okay. So I hope you guys have written the formula down. Let's do some examples. Let's get familiar with this formula and see how it works. Okay. So here's an example. And we will start with ungrouped. Okay, we'll start with ungrouped data and we will use method 1. And what's the first method? The method is this one. We'll use this formula. Okay, let me copy paste it. Okay, now let me write down a couple of values and then we'll see what's what. So let's say you have 0, 0, 1, 1, 1, 2, 3, 3, 4, 4, 4, 4, 1, 2, 3, 4, another 4, 5, and 5. Okay. So how many values do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Now in both the methods, one thing that you have to do is you have to calculate the mean. Okay. So the question here is, to find the mean and variance. Okay, so you have to find out the mean and the variance. Let's start with the mean. Mean is something that we're all familiar with. Okay, we can do that in a second. So mean or x bar can be found out by simply doing 0 plus 0 plus 1 plus 1 plus 1 plus 2 plus 3 plus 3 plus 4 plus 4 plus 4, 5 times 4, 1, 2, 3, 4, 5 plus 5 plus 5 divided by the total frequency, which, as we saw, is 15. Let's work this out, see what do we get. So how many times do we have 1? We have 1 a total of 3 times. How many times do we have 2? Just once. How many times do we have 3? We have it twice. How many times do we have 4? That is 5 times, so that's going to be 20 plus 10. So that's 41 divided by 15. So that's 2.73. Okay, 41 upon 15 or 2.73. Okay, 2.73 with a bar because it is what do you call? It's recurring. In fact, a काम करते हैं. Hang on. I hope you guys haven't copied this. I don't want to deal with decimals. So instead, in the same data set, let's add. Yeah, चलो ठीक है. Let's just let it be 41 upon 15 or 2.73. ठीक है? So nothing new so far. Now, if I want to calculate the variance, here's what we're going to do. Now, I want you guys to understand this formula. Don't just memorize this formula. I want you guys to understand and see how this formula works. The first thing that we're going to do is we're going to do x square. What does that mean? That means we are going to square all terms. So this is the first step. The first step is that we're going to square all the terms. That means 0 squared, 1 squared, 2 squared, all of that. The second step is summation x square, which means that we're going to sum all the terms. Okay. Then the third step. And what's the third step? The third step is summation x square upon n, which means divide the sum by the number of terms. Divide the sum by the number of terms. Okay. Then comes step 4 and the final step, which is minus the square of mean. And this is pretty straightforward, which is subtract the square of mean. All right. So let's do this. Here we go. We're calculating the variance now. So sigma squared adding, no, of course that's wrong. We need to add the squares. We don't have to add them and then square them. We need to add the squares of the terms. So sigma squared is going to be equal to 0 squared plus 0 squared plus 1 squared plus 1 squared plus 2 squared plus 3 squared plus 3 squared plus 4 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 squared. How many times do we have 4? 5 times. 1, 2, 3, 4, 5. And then plus 5 squared plus 5 squared divided by, so that's the first step, divide by the number of terms, which is 15. And from this, what are we subtracting? We're subtracting the square of the mean. Okay, I missed a 1? Yeah, I missed a 1. Okay. Yeah, okay. Thank you for pointing that out. All right, now let's do this. So here we get 31 upon 3 minus 41 upon 15 whole squared. Now I've worked this out from before so that we can save some time. So the final answer is 2.86. So that means the variance sigma squared is 2.86. And that is how you calculate variance. Okay, now I'll repeat. In order to calculate variance, this is one method to do it, which is that you find the square of all the terms, you add them up, you find the square of all the terms, you add them up, you divide the sum by the number of terms, and then from that answer you subtract the square of the mean, and that's how you get variance. Okay, this is one method. Now let's look at the other method. Yes, so the prerequisite of variance is that you have to know the mean. So sometimes the question will be a straightforward question. It'll ask you to find the variance, which means it's going to be more marks because that means you'll be marked for calculating the mean correctly as well. But sometimes the question will be structured in a way that in one part it's going to ask you to calculate its mean, and then in the following part it's going to ask you to calculate the variance or the standard deviation. The answer that I got is 2.86 here. Now let's look at the second method. The second method is slightly more lengthy. Okay, because we have a lot of calculation, a lot of values that we need to write down. And if you remember, that's what I said in the first class, that you got to have a good grip on your calculator because there are some very lengthy calculations that you will have to do. Okay, not in every concept, not in every topic, but in a few topics, and this is one of those topics. Okay, can we do 1 square into 3? Okay, for 1, yes, you can. Okay, and for the rest of the terms, yeah, of course, any shortcut that you can apply, that's fine. That's okay.
I have a question.
Yeah, go ahead.
Sir, where did this 31 over 3 come from?
Oh, that's just a simplified version. That's just a simplified version. Since I worked this out before, I wrote the simplified version. Let's do it right now. So if you add this, you get 1 plus 1 plus 1 plus 4 plus 9 plus 9, and you're going to have 16 a total of 5 times, so that's going to be 80, and then 25 and 25, so that's 155 divided by 15. So basically you get 155 divided by 15, and then if you simplify that, your calculator gives it to you as 31 upon 3. Dekho, you get 155 when you add the squares of all the terms, divide by 15, minus 41 upon 15, the whole thing square. Okay, and 31 upon 3 is just a simplified version of 155 over 15.
तो basically अगर आप like इसको square करेंगे तो answer जो है वो फर्क आएगा as compared to, because first वाले में you did not, the terms are the same but you just didn't square it, right?
Yeah.
When you found out the mean.
Yeah.
So and then secondly you subtracted it with the square of the answer, with the square of the mean basically.
Yeah.
Okay, sir.
Okay. Here, okay, please don't make that confusion that you add all the terms and then square it. Okay? That's different. What we have to do is we have to add the square of all the terms and then divide by the total number of terms. Okay? Yeah, I can show the previous page. Here it is. Bedullah, let me know when you're done having a look. I got 2.88. How'd you get 2.88? No, if you've gotten 2. Okay, I know why you've gotten 2.88. You probably subtracted 2.73 squared. Is that what you did, Kabir? You subtracted 2.73 squared? 2.88 is not correct, no, because you're using a rounded off value. The reason why I didn't use a rounded off value is because in that case there would have been, my answer will not be close to the correct answer. So since this is not your final answer, do not use any rounded off values, okay? Use the actual value, use the fractional value, or if you don't want to use 41 upon 15, then use 2.73, but use more decimal places. Use 5 significant figures, okay? Yes, you have to use fractions. Again, don't make a standard rule out of this. The idea is to use the values close to the original values as possible. Okay? Now, I'm afraid if I say you have to use fractions, then you will not understand the context of what I'm saying. We have to use the values as close as to the original values. Okay, that's the reason. So if you have a recurring decimal, it's best to write it in fraction form. Okay. All right. Now this is one method. Now we're going to look at method number 2. And let's see what method number 2 is. So here is method 2. Okay, and method 2 is this formula. Now, can you guys decipher this formula? I know, I mean, I don't expect you guys to be able to do this flawlessly, but give it a try. What do you think we're going to do in this one? X minus mean, yeah, that's correct. Good job. And then, what are we going to do? And square them, yes. And then add them up, and then divide by the number of terms. That's correct. Okay, so here's what we're going to do. Again, this is going to be a 4 or 5 step process. Let's write it down. X minus x bar basically means subtract mean from each value. Okay, so we're going to have to subtract the mean from each value. X minus x bar, the whole thing square, means that you square them. Okay, and then summation x minus x bar, the whole thing square, means that you then add them. Okay, add the result. Add the result of what? Add the result of step 2. Add the results of step 2 actually. And then comes step 4, which is summation x minus x bar, the whole thing square, divided by n, and that is divide by the number of terms. Okay. Yep, too much work. That's how it is. Welcome to S1. Which is why, remember, if you're doing S1, okay, if you're doing the exam, You literally don't even have a minute to spare. If we can use, yeah, okay. Dekho, we can use the first formula. I know that's always a go-to question, but there will be instances where you have to use the second method. Okay, there will be instances where you have to use where you can only use one method. Like for example, how many ways can we solve two equations simultaneously? How many ways do we know? Two ways. Okay, can you name them? What are those two ways? Substitution and elimination. Is it safe to say, you know what, I don't like elimination, I'm just going to stick to substitution? Is that a good approach? Yes or no? Why not?
Because you never know that what comes to rescue.
Exactly, you never know where you, because we know actually that we can't use substitution, we can't use elimination everywhere. Okay, there will be a point where I will have no option but to use substitution. Okay, just like that, can I say that, you know what, I don't like the quadratic formula, it's too much work, I'm just going to do middle term breaking? Well, if you do that, you're going to be in, at some point, yes, you're going to end up in big trouble, because there will come a point where you can't do middle term breaking, you got to use the quadratic formula. Okay, so please, if there are multiple formulas, if there are multiple ways of solving the same question, you got to learn both of them, because at one point you can only use just one of them. Okay, so I hope I won't have to repeat this again and again. All right, now here are all the values. I'm just going to write them down. 0, 0, 0, sorry, 2 zeros, 3 times 1, and 1, 2, 2 times 3, and 5 times 4. 1, 2, 3, 4, 4, and 5, which occurs twice. Now, you guys are probably wondering why I've made this table. I made this table for simplicity. Okay, so let me count first of all, make sure that all the terms are okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, just one more term, 5 to add. So is it okay to use the calculator to automatically do the middle term breaking? Okay, I've answered this question. I've literally forgotten how many times I've answered this question. It's okay to use your calculator to check your answer. Okay, if it's a 4-mark question and you just use your calculator and write the final answer, please don't expect any marks. Okay, just use your common sense. What do you think the examiner is giving you your mark for? Of how advanced your calculator is? Obviously not. You're not going to impress the examiner by how well or you know how to use your calculator, or how advanced your calculator is. You got to show you the working. Okay, so just use your common sense. You'll find the answer to these questions. Okay, now let's get to work. X minus x bar. Remember what we're doing is we're subtracting mean from all these values. Okay, we're subtracting mean from all these values. So the mean turned out to be 2.73. So since 2.73 is not the exact value, I'm going to take this to be 2.733. Okay, so what is 0 minus 2.733? That's going to be minus 2.733. Okay, and then again 0 minus 2.73, that's also going to be minus 2.733. 1 minus 2.733, that's going to be 1.733. Okay, then again 1 minus 2.733, that's going to be 1.733. Okay, and then again 1 minus 2.73, that's going to be 1.733. So I hope everyone knows what I'm doing. I'm taking every single value and from it subtracting the mean, which we worked out earlier. 2.733. Sorry? Yeah, of course, there should be minus. Thank you for pointing that out. Okay, then we have minus 0.733, and now it's going to be 0.27, 0.277, actually, 0.277. 4 minus 2.73, that's going to be 1.277. Again, 1.277. Again 1.277, again 1.277, again 1.277, and then 5 minus 2.733, that's going to be 2.277, and then 2.277. Okay. Jannat, hang on. Don't worry about. At this point, the objective is to learn both the formulas. At this point, our objective is not to be able to figure out when to use which formula. At this point, the objective is to learn the use of both the formulas, because like I said, at some point you will have to use, there will come a point where you can only use one. Okay, So don't waste your time trying to figure out trying to figure out ways where we can use one formula or where we can't. I will tell you that. But at this point, learn both the formulas. ठीक है? फ़ौरन से शॉर्टकट ना ढूंढने लग जाया करें आप लोग, ठीक है? फ़ौरन से अपनी जान ना छुड़ाने लग जाया करें. पहले मेथड को समझ लें, फिर अगर दोनों मेथड्स ऐसे हुए, where you can just use one and not the other, you can stick to one. But make sure that you learn both the methods. That's the correct approach. Okay, now we start squaring them. So the square of minus 2.733 is going to be 7.4529. Again, 7.4529, and then the square of minus 1.733 is going to be 2.9929, and then 2.9929 again, and then 0.5329 again, no, wait a minute. This also will be 2.9929, and then this is going to be 0.5329, 0.0729, 0.0729. 1.27 squared is going to be 1.6129. Now, since we have so many of these, I'll just copy paste them. Okay, 1.6129, and then the square of 2.27 is going to be 5.1529, and then again 5.1529. Okay, so what have we done so far? We have subtracted all the values. We have subtracted mean from all the values. We have squared them. Now what we're going to do, we're going to add them up. Okay, so here in this column, we are going to add them up. Okay, and this will give us what? This will give us summation x minus x bar, the whole thing square. Okay, all right. Now if you add them up, what do we get? Let's see. Now, I've done this before. Okay, I've written the sum here so that we can save some time. So the answer is 41.3206. Okay, so here's what we're going to do. We're going to do 41.3206 divided by 15. And this is going to be your variance. Why? Because this is summation x minus x bar, the whole thing squared upon n. So the variance, sigma squared, is 2.76. Now notice that there is a small difference in this value and in this value. What do you think is the reason behind that? There's a small difference in this value, although they're very close to each other, but there is still a small difference. What's the reason behind that? Any idea? Yes, because the values that I'm using over here are, although not correct to 3 significant figures, we have what, 4 or 5 significant figures, but still they're not the exact values. Because we're using slightly rounded off values, we're not getting the answer close to the exact answer. Okay, so once again, why are we getting a small difference? The difference is of 0.1. Yeah, there's a 0.1 difference. So the reason why we're getting that is because we're using slightly rounded off values. Okay, the mean is not actually 2.733, it's 2.73, and 3 is recurring. Okay, so since we used a slightly rounded off mean, and these values also, I'm using them as slightly rounded off, we're not getting the exact answer. Now you guys tell me, which method you think is better? The first method. Okay, now that doesn't mean that you can completely let go of this method. In this particular scenario, yes, the first method is better. Okay. Okay, now, before we do how to calculate the variance of group data, first let's summarize what we have done. Okay, so first of all, what is variance? Variance is a measurement of the spread between the numbers in a data. In simple terms, it helps you find out how consistent the values are. Okay, the lower, what's better, the higher the variance or the lower, or the higher the variance or lower the variance? What's better? Yeah, the lower it is, the better it is. Okay, because the lower it is means that the closer your values are to one another. Okay, now how do we do that? How do we calculate variance? We're talking about ungrouped data right now. We're not going to talk about group data just yet. For ungrouped data, this is what we do. One method is that you sum the square of all the terms, divide by the number of terms, and from that subtract the mean. The other is that you first find the difference of all the values from the mean, meaning you subtract mean from all the values, then you square them, then you divide by the number of terms. Okay, so both these methods, they're not substitutes. Okay, please don't think of these methods as substitutes. They're both equally applicable depending on the situation. Okay, and yes, these formulas will be given, but like I said earlier, if you have to do a lot of back and forth, that means you haven't practiced enough. Okay, now here we have some values. We learned how to find out the variance. So first we found out the mean, which you will have to irrespective of the formula that you're using. Then we squared all these values, we added them up, divided by the number of terms, and from that answer subtracted the square of the mean. Okay, that's one method. The other method is that you list down all these values, and from these values you subtract the mean. Okay, you do that for every single value, then you square that answer, then you add all these values, and then divide by the number of terms. Okay, so I will give you guys a question to solve. Take your time. I understand this is the first question that you guys are doing, so focus on getting the right answer, not on getting the um, not on completing the question first. Okay, so find the variance, find the mean and variance. Go ahead. Find the mean and the variance. Mean is something that you have to find. It's given over here, but you also have to find the median as well. So in that case, you have a certain range of acceptable answers. Okay, you will have a certain range of acceptable answers, but that doesn't mean that you can be very casual about it. It's not going to be a very extensive range, but there will be a range. Okay. Yeah, so the mean is 2.36. Good job.
So can you write the formula?
Yeah, sure. Did you not write down the formula?
Sir, I make notes later.
Okay. Well, formulas are such that you should write them down. You should write them down while I'm writing them, because it'll help you memorize them soon. That is the correct answer. Good job. So the variance, or sigma squared, is 2.2304. Okay, at this point you can round off your answer, which is 2.23. Okay. Achha, also remember what standard deviation is. Okay. Now we are going to go into the theoretical part later, but if you're asked to find out the standard deviation, what is it? It's the square root of the variance. Okay, write this down in words also. That standard deviation, and here's the symbol. Standard deviation is the square root of the variance. So you don't need to know a new formula for standard deviation. Just remember that if you're asked to find out the standard deviation, you take the square root of the variance. Okay, or you can just put a square root around this formula. Okay. All right. Now, so once again, the correct answer is 2.2304, or we can say 2.23, correct to three significant figures. Okay. Make sure to read the question carefully. Sometimes the question will have a certain restriction, so you got to fulfill that. Okay. Now let's see how we can find out the standard deviation or the variance of group data. Okay. Yeah, standard deviation will be 1.49. Although not asked here, but if the question said the standard deviation will be 1.49, the square root. Yeah, chalo likh lete hain. ठीक है, might as well. So if the question said standard deviation, which means the square root of the variance, so that's going to be the square root of 2.23. Let's see what that is. 2.2304 square root 1.49. Initially, you might have a bit of confusion distinguishing between the symbols, but the sooner you get the hang of it, the better it is. Again, if you remember, that's what I said in the first class, that a couple of pitfalls are that there's a lot of calculations, so students who don't have a good grip on the calculator will tend to struggle. Students who fail to distinguish between the symbols will also tend to struggle. Okay, so the sooner you get the hang of it, the better it is. Okay, now we have around 15 minutes, that's plenty of time. Let's see how to calculate the standard deviation of group data. Okay, standard deviation or variance, same thing. Okay. So I'm going to use a question from the book. Here it is. Your calculator is lagging. I would recommend something like this, a Casio class-based calculator. And yes, you gotta have an advanced calculator. If you have, even by the way, even a calculator like this one will at some point lag if you have a lot of calculations. So you just gotta be patient with it. Okay. Yeah, or original one, ideally. So let's say that we have to calculate the mean and standard deviation of the following data. Now this is, yes, it's group data, but it's discrete. Okay, it's grouped, but it's grouped in discrete form. Yes, they are available. Get it from a well-reputed stationery near your house. So chances are that you will find an original one. Okay, they're quite mainstream. They're not that difficult to find. Okay, so the question here says find the mean and standard deviation of the following data. Let's take this to a fresh page because there's going to be a lot of work. Now, if you look at this formula, you will notice that this formula is not any not any different from the previous one, except that once you found x square, you multiply that by the frequency and then sum it up. Okay, so if I want to find out the mean, let's start with the mean. How can I find out the mean? The mean is going to be summation fx over summation f. So let's see. Summation fx means that 2 into 3 plus 5 into 4 plus 8 into 5 plus 14 times 6 plus 9 times 7 plus 4 times 8 plus 3 times 9. This will give us the summation fx. Divide by the total frequency. It's not given, so we'll have to work it out. 2 plus 5 plus 8 plus 14 plus 9 plus 4 plus 3. So that's equal to 45. Okay, let's work this out. See what do we get. Anyone who can work this out and tell me what the answer is? In the meantime, I'll just look at the answer from the back to save some time. Yeah, 6.044. Good job. 6.044. Recurring decimal. What's the fractional value?
94 upon 15.
94 upon 15? 94 divided by 15. No, it can't be 94 upon 15. 272 divided by 45. Okay, that's correct. 272 divided by 45. Yes, I'm using the Cambridge book and I've already uploaded a soft copy of this in the shared folder, the link to which you will find in the description of the group. Okay, so now that we have the mean, let's focus on the standard deviation. Remember what the standard deviation is? It's simply the square root of the variance. So we will not do anything differently up until the very end, and that is we're going to take the square root. Okay, so let's start calculating the variance. This is the formula that I'm going to use. So a good idea would be to add an extra column. And what will I do in that extra column? What do you think I will write down? Sorry, an extra row. What should I write down in this extra row? I should write down x square. Okay, so in this row, I will write down all the values of x after we square them. Okay, so here I will write down x square. So 3 squared, remember you're squaring x, okay? Don't end up taking the square of frequency. 3 squared is 9, 4 squared is 16, then 25, then 36, then 49, and then 64, and then 81. Okay, so what are we doing now? Then we're going to multiply these values by the frequency. So that means 9 into 2, okay, plus 16 into 5. Since we're multiplying, the order you can change. It doesn't matter in the sense that you can write 5 into 16 or you can write 16 into 5, makes no difference. Plus 25 into 8, plus 36 into 14, plus 49 into 9, plus 64 into 4, plus 81 into 3, and this gets divided by the total frequency, which we worked out earlier, and that is 45. And that's not it. From this, we're going to subtract the square of the mean, which is 272 upon 15, the whole thing squared. Okay, let's work this out and see what do we get. Now, make sure that you're using your calculator very carefully over here. It's important that you make brackets, okay? So 9 times 2 in a bracket plus 16 times 5 in a bracket plus 25 times 18, sorry, 25 times 8 in a bracket.
1742 divided by 45.
Sorry?
1742 divided by 45.
All right, thank you. But let me just work it out anyway. 36 into 14, close the bracket, plus 49 into 9, close the bracket. Make sure you don't end up making a typing error, otherwise the whole answer is going to be incorrect, okay? Plus, close the bracket, 64 into 4, close the bracket, plus 81 into 3, divided by 45. So, yep, you're right, 1742 divided by 45. And from this, we're going to subtract the square of the mean, which is 272 upon 15, the whole thing square. So let's do that. Minus, make a bracket, 272 upon 15, the whole thing square. So what do we get? Here's what we get. We get, just a minute. Wait a minute. 1742 upon 45 is correct, but 272 upon 15 is incorrect. It's not 272 upon 15. What's
272 upon 45.
272 upon 45. Sorry, my bad. I don't know why I wrote 15. Sorry, my bad. Yeah, so 272 upon 45. Okay, so let's do this again. 1742 over 45 minus 272 upon 45. Close the bracket, the whole thing square. So the variance that we're getting is 2.1758, and then in order to calculate the standard deviation, which is what we're asked, we get 1.475. So we'll write 1.475, and then in the end, we'll give an answer correct to 3 significant figures, which is 1.48. And that is your final answer. Yes, Fatma, you were saying something? Variance. We found out the variance first, and then we found out this. So, देखो, first of all, don't be confused between variance and standard deviation. Once you've worked out variance, all you got to do is take the square root of it to get the standard deviation. Okay? The question is, how do we calculate the variance? I think that's what your question is. Variance में आपको confusion है कि?
Exactly, sir.
देखो. So I'll tell you variance कैसे निकालेंगे. Obviously, I'm not going to do the whole working. So 0 squared plus 0 squared plus 1 squared plus 1 squared. Okay, I've skipped a few terms. Plus dot 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 4 squared plus 4 squared and then plus 5 squared plus 5 squared. So basically what you have to do is remember the step-by-step process. What's the first step? The first step is that you square all the terms. Okay, so write down all these terms after you've squared them. Okay, maybe you can make another row and that's where you can write all the terms. The second step is that you sum all of them. Okay, you sum all the terms. Then the third step is you divide the sum by the number of terms. So once you found the square, once you've added them, then you divide by the number of terms, which I believe is 25 here. Yeah. And then from this answer, you subtract the mean, the square of the mean. Okay, do this and you'll have your answer. If you're not getting the correct answer, chances are you've probably made a calculation error or something. And this, by the way, will give you the variance. And then if you want the standard deviation, just take the square root of the variance and you will have the standard deviation.
Sir, हमने 15 से ऐड करना है. ये 15 नहीं है सर इस केस के अंदर.
15 or 25 है? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 25 है. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 है. 15 किसी और सवाल में था. 15 I think पिछले वाले सवाल में था. इसमें था 15. Yeah.
Right, sir. Get it, sir.
Okay.
Thank you.
Yes, there is plenty of room, Fatma, to make a typing error in your calculator. Okay, which is why you got to be careful. Okay, I'm going to give you guys one question to solve. And here it is. It's the time. What do you mean by that, Fatma? Yeah, I know. We still have 5-6 minutes. And I don't think there's any harm in extending the class 5-7 minutes. Obviously not an hour. But 5-7 minutes I don't think is a problem. At least we can get something done. Okay, so here what you have to do is you have to find the mean and standard deviation of the number of goals each player scored. So that means you got to work it out separately for Mahmoud and separately for Rahim. And then you have to comment as well. Okay, so here's a bit of theory. I will let you guys figure this out, this part. Okay, but obviously for that you will need your answer to the first part. Okay, so do that and then tell me what is your comment on the scoring record. So I'll give you 5 minutes, plenty of time. You can use the first method here. No need to use the second one. Yep, 31 upon 30. Sorry, I just saw your answer. 31 upon 30 is the correct answer for the mean. Now go ahead and do standard deviation. Yes, Anaf, I can read your messages. Did you ask a question? Yeah, I think you asked a question which I missed earlier. Oh, yeah. Okay, I got your question. Tero, I'll answer it. 31 upon 30 is correct. 31 upon 30 for both? Yeah, 31 upon 30 for both.
I have a question.
Mm-hmm.
In this case, do we have to do it separately, like first for Mahmoud and then for Rahim?
Yeah.
And then we add the means?
No, you don't have to add their means. It's two different data sets. Okay, so you're working with two different data sets. It's like you're solving two questions. So you will first find the standard deviation of Rahim and then you'll find the standard deviation for Mahmoud. Okay, you don't have to combine them. That is, by the way, that is a separate topic, combined mean and combined standard deviation and variance, but you don't have to do that over here. Okay, so Hanaf has basically asked a question, and the question is, apart from being a square root of variance, what does standard deviation mean in describing a data set? Okay, so variance basically tells us how close the values are to the mean in the data set. Okay, so variance tells you how close the values are to the average in their given data set, whereas standard deviation tells us how close the values are to one another. Okay, so understand the difference. If you have the variance, you know how close the values are to the mean or the difference in values from the mean. Standard deviation tells us how close the values are to one another. Okay, that's what the difference is. 1.098. I'm afraid, Rabia, that is not the correct answer. No, it's not like precision and accuracy. Precision and accuracy is something else. Precision is, I believe, how close your values are to one another. Accuracy is how close the value is to the actual answer, right? But in a way, you can say that by definition, yes. But here we don't really have a right or wrong answer. In physics, you have a right answer, right? That's accuracy. But here we don't have that. Yes, 1.05 is correct. 1.05 is correct, and 1.05 is for Mahmoud. 8.242. Does that make sense? 8.242. I mean, we're looking at goals that go from 0 to 4. So how can the standard deviation be 8.242? So chances are you made a calculation error, Zernisha, which is very common. I'm not surprised if you guys make a calculation error, and I want you guys to be conscious of it, that calculation errors are very common, so just deal with the questions accordingly. Okay, now anyone who's worked out the standard deviation for Rahim? Good job. So the standard deviation for Rahim is 0.55. Okay. Good job, Mahad. Now comment. If you had to pick a player, which one will you pick? If you had to pick a player to play with you in your team, why would you pick Rahim?
Less deviation.
Less deviation. Okay. Less deviation, which means he is more consistent. That's correct. Okay. So when you're writing your answer, you're not going to make very long, extensive statements. You're going to say, comment on the player's goals. Okay. Since you have to comment, all right. So this is how you comment. You say, while their average is the same, Rahim has a lower standard deviation, therefore is more consistent. Okay, so now you guys can probably see why just the average is not enough. Okay, just the average is not enough. In fact, you can see both of them have scored the same number of goals. Mahmoud has scored 31. He has also scored 31. Okay, but that's just not enough. It's possible that Mahmoud has had a lot of bad days, but one good day where he scored a lot of goals. Rahim, on the other hand, could have had all days as fairly average, and that's what makes him more consistent. Okay, in fact, you can see that. Rahim, yeah, Mahmoud had 12 days where he scored 0 goals, okay, and he had 8 days where he scored 2 goals. Rahim, on the other hand, you can say his data is fairly well distributed. Okay, but that more about that later on. But Rahim, you can see, since he has a lower standard deviation, that means he's more consistent compared to Mahmoud. Okay. How less deviation tells us good player? Does it mean no? Okay, less deviation. It's not derivation. It's deviation. First of all, less standard deviation means that the values are close to one another. Less variance means that the values are close to the mean. Okay, let's write this down. I didn't write this down when we were writing down standard deviation. Okay. So variance basically tells us how close the values are to the mean in a data set. Standard deviation basically tells us how close the values are to one another. Okay, and variance and standard deviation are those things that the higher they are, the higher they are, that's not a good sign. The lower they are, the better they are. Okay, the higher they are, the worse they are. The lower they are, the better they are. Okay. No, I don't. I do teach P3, but I'm not teaching P3 this year. Okay, next year I will be, inshallah. Can you take my question? Yeah, sure, Fatma. What's your question? Okay, we're done with the class officially, by the way. If you guys want to leave, go ahead. I will give you guys some homework. Okay, the idea of homework is so that you guys can stay in practice. It's very easy to forget these formulas, very easy to lose track of how these formulas work. So for that, to make sure that doesn't happen, I'll be giving you guys homework. Make sure to join Google Classroom, the link to which you will find in the description of the WhatsApp group. Okay, that's where you'll find the recording and the notes and everything that you guys need. Yes, Fatma, what's your question? The rest of you guys can leave. Allah Hafiz. Yeah.
It's the one that I sent you.
In the group? Or send me individually?
No, but I can send in the group.
No, it's okay. You don't have to send it in the group. So, Barira, what I said was that the lower the standard deviation, the better it is. Okay, so if you want to pick a player, doesn't matter a football player or a cricket player, the lower standard deviation he has, the better it is. That means the more consistent he is. Okay?
Sir, a question related to this particular question.
Bolo.
Sir, I think मेरी variance थोड़ी गलत आ रही है, इसी वजह से answer गलत हो रहा है.
बताएं.
In case हम variance के लिए we multiply goals scored, we like square goals scored, right?
Yeah, 0 squared into 12 plus 1 squared into 8 plus 2 squared into 8 plus 3 squared into 1 plus 4 squared into 1.
And then we'll divide by 30.
Yeah, we'll add them up, of course, then we'll divide by 30. And then we will subtract the square of the mean.
Right, sir.
Okay, so I'll stop here. See you guys, inshallah, on whenever our next class is. I think it's on Tuesday. Yeah, so see you guys on Thursday. Okay, Thursday. I'll give you guys homework. Make sure to do that. Okay, very, very important. Don't take it lightly. So once again, take care. Hafiz.